This is the setup in which we're going to try to determine what the value of the gas constant R is. And to do so, we have to determine experimentally what the pressure, temperature, and volume of some, and the number of moles of some sample of gas is. This looks like a fairly complicated setup, and it's a little bit complicated, so let me show you what we're going to do. We start with a sidearm Erlenmeyer flask, or sometimes called a filter flask, with a piece of glass tubing going through a rubber stopper, which will fit into the neck of a large test tube. And in that test tube we have some potassium chlorate and a little bit of manganese dioxide. When that mixture gets heated by the Bunsen burner, it will produce oxygen gas. The oxygen gas will be forced through this tube into this container. There will be some water in this container. That water will be forced up through this tube and over into the beaker. We'll then measure how much water came over. We'll measure what the total temperature is in the apparatus. We'll measure what the pressure is in the apparatus in a very ingenious way, because the pressure in the apparatus is going to be the same as the atmospheric pressure, which we can measure easily. And we'll know the number of moles because we'll take the mass of the test tube before we started and the mass of the test tube after we finish, and the difference will be the weight of the oxygen that was produced. And if you know the grams of oxygen, you know the moles of oxygen. So we'll have moles, we'll have pressure, we'll have temperature, and we'll have volume, because we'll know the volume of water that came over. So that's the main idea. In order to get started, we need to have water in both the beaker. So I'll just put some water in there, a fair amount, and also in the flask, we need to have a fair amount of water. Make sure the rubber stopper is in there tightly. And then what we're going to do is blow water from here over to there and then suction it back again using this suction device, which we'll just attach on the end of that. And I'm going to start blowing water over towards that side and then suctioning it back over towards this side. And notice that there's some bubbles initially, but once we've established a complete water bridge from one side to the other, then there's no air bubbles trapped in here, and it's completely filled with water all the way along. Okay. If I were to take the bulb off of here, then water would siphon in one way or the other, because by establishing that water bridge, we've established a siphon. So what I'm going to do is, first of all, suction some more water over towards this side so that that container is pretty full of water. We don't want to get up to the sidearm, but we want it to be pretty full. And then I'm just going to quickly attach it onto the test tube. And by attaching it here, no air can get into this side of the system, and so it can't siphon. But this is an important thing we're going to do next. Now notice that I have this pinch clamp on here. At the moment it's sitting on the glass tubing that's in here, so it's not pinching off this tube. But in a minute I will move it so that it's pinching off the tube. At this point what I want to do is level the two sides. So I'm going to raise or lower the beaker. I can just hold it right over here. Move this out of the way. And I want the level in here to be the same as the level in here. Okay, there we go. They're about the same level. Now by doing that, I've allowed water to move one way or the other, such that the pressure inside here is the same as the pressure outside. And then I'm going to close off that tube. Now by doing that, I've assured that the pressure inside the container is the same as the pressure in the atmosphere, which we can measure easily. Okay, now here comes the tricky part. I need to get the water out of here and into there without letting any air get up inside the tube. And normally this is done with two people and it's a little bit easier, but watch what I'm going to do here. I'm going to very carefully pull that out. Hopefully no air gets up inside. Just going to dump that. Just going to briefly dry container. It doesn't have to be real dry. I'm going to hold the pipette down in the corner of that beaker down there, and I'm going to unclamp the pinch clamp. In so doing, I don't know if you can notice, but a small amount of water has come over into the beaker. Not a lot, and if it keeps on coming at that point, then you know that you have a leak somewhere. But I think at this point we're fine. I'm going to carefully hold the tip of that pipette under the water in the beaker. And as long as that tip stays underwater, no air can get up in there, and we're fine. That's what we want to happen. Now, at this point, I'm going to light the Bunsen burner. Reduce the gas down some. Don't need a very hot flame at this point, just a small flame will do. And now what we're going to do is watch the level in here, and when I start heating the potassium chlorate, as I said, oxygen is going to come over, it's going to force the water down in that container over into the beaker, but we want to make sure that the water level in here never goes below the bottom of that long tube that's inside that flask. If it gets below there, air will get up inside, and we don't want that to happen. We want to trap it all in this area. So I'm simply going to start heating the test tube very gently here, and it'll take a few minutes to get hot enough, but pretty soon what you will see, and I don't know if you'll see it on the video or not, but you'll see that the potassium chlorate in the test tube actually starts to bubble, which will seem strange because it's a solid, have a kind of solid bubble, but it does. It's kind of interesting how that happens. And as soon as it does, you'll notice the level of water in that beaker is decreasing. In fact, you may notice the water level in the beaker over there is actually increasing at this point, so it's beginning to happen even though I don't see bubbling yet in the potassium chlorate. See more water going over into the beaker over there? Now it's beginning to bubble in the test tube. Pretty soon it's going to start happening very fast. You'll notice the level in here will start to go down pretty quickly. When that happens, you want to take the heat away because you don't want the level in that flask to go below the bottom of that tube. I don't know if you can see in there, but it's really, stuff's beginning to happen in the test tube. We're getting quite a bit of water now in the beaker, and this level in here is decreasing somewhat. Now, a question always arises at this point is, when do you know you're done? Well, you can stop it at any point as long as you have significant amounts of water coming over there. The more the better. But again, you don't want the level in this flask to go below the bottom. So I'm just going to keep on heating it and keep on producing oxygen. Okay, it's going pretty fast now, so I'm going to stop. I'm just going to let it stay as is, not going to touch it at all. I'm going to go ahead and turn off the Bunsen burner because we're done with it at that point. And now what we do is we just wait. What we need to happen is for the temperature of this part, which is very hot since we've been heating it, I need that to cool down to room temperature. So this is where you just sit and you wait. And as that's cooling down, of course, as the gas cools, the pressure decreases, water will be suctioned back over this way. So you need to keep the clamp so that it's not clamping off the tube. You actually want water to flow back over to the point where it's the whole thing, the whole apparatus is at room temperature. Okay, is the tube cool enough now? It's still a little warm. We're going to let it sit a few more minutes. Okay, so now we carefully touch the test tube and we see that it is absolutely stone cold, same temperature as the surrounding air. So we have to do that leveling thing again one more time. So we'll take the beaker and we'll hold it up here next to the flask. Make sure the level on one side is exactly in line with the level on the other side, just like we did before. Now we'll take and close off the water bridge between them. Carefully remove the tube from the beaker and we're done. So we're going to weigh this water or just put it in a graduated cylinder and see what its volume is. We're going to measure the temperature of the surroundings by just looking at a thermometer. We're going to measure the atmospheric pressure by using a manometer or possibly just looking it up online. And we're going to weigh the test tube. We weighed it before, we weigh it after, and the difference is the weight of the oxygen. With that data, we can calculate the value of R. Thanks for your attention.